Day 685 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 3212, count submatrices with equal frequency of x and y. The difficulty level is medium, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, subscribe, comment, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. Given a 2D character matrix grid where grid of I and j is either x, y, or a period, return the number of submatrices that contain grid of 0, 0, and equal frequency of x and y and at least one x. All right, y'all, so that sounds simple enough, but let's go ahead and take a look at these examples just to make sure that we are doing this problem correctly. So in example 1, we have our input grid equals a 2D array of integers, or each row in the grid. The first row is x, y, period. The second row is y, period, right? So as you can see, this right here is the first row, top row, and this right here is the bottom row. Boom. And we want to return the number of submatrices that contain grid of 0, 0, and equal frequency of x and y and at least one x. But first, let's see what a submatrix is. It says a submatrix x1, y1, x2, y2 is a matrix that forms by choosing all cells matrix of xy where x1 is less than or equal to x, x is less than or equal to x2, and y1 is less than or equal to y, and y is less than or equal to y2. Boom. So let's go through this. Because the output is 3, that means we were able to form 3 submatrices that contain these requirements right here. So the first requirement, it has to use the grid 0, 0, which is this top left, right? So every submatrix needs to include this top left cell right here. Boom. As you can see, every submatrix in the output, they all include the top left cell. The top left cell, that is 0, 0, grid 0, 0, point 0, 0, boom. Then it also needs to have an equal number of x and y. So as you can see, this submatrix has x and a y, that's one x and one y. This submatrix has one x and one y, and this submatrix has one x and one I. But you can see this submatrix includes a period, which is fine because it still fits all of the other requirements. Then it says it has at least one x. This has at least one x, this has at least one x, and this has at least one x. Now, you might wonder, why can't we just make a submatrix like this square right here? We can't just make this square a submatrix because then that would have two y's. It would have this y and this y. And remember, it needs to have an equal frequency of x and y. So that's why we can't just include this y in any of our, or why we can't include two y's in any of our submatrices because there's only one x. Boom. In this case, out of this grid, we were able to create 3 submatrices, so that's why the output is 3. Now, just in case that didn't make sense, let's take a look at example 2. So in example 2, we have our input grid equals an array of integers, or an array of a 2D, sorry, y'all, let me back up, I'm moving too fast. A 2D array of strings. Once again, each array represents a different row. So let me go ahead and copy and paste this so y'all can see what I mean by that. Boom. Put this over here. Boom. So this is what the matrix would look like, right? And as you can see, it's impossible to create a submatrix with an equal number of x, y, because we cannot get to this y without including these other x's, right? We can't just make a diagonal submatrix. That's not going to work. So since that's not going to work, our output is 0. Now, just in case that didn't make sense, let's take a look at example 3. Example 3, same thing. We have the input grid equals a 2D array of strings. Each string represents a different row. So first we have period, then we have period again. So let's go ahead and just copy and paste this since it's the same string. And as you can see, this matrix doesn't even have an x or a y at all, and it needs to have at least one x, right? So since there's no x's, then there are 0 submatrices that we will be able to create, so the output is 0. Explanation says no submatrix has at least one x. Boom, y'all. So I hope that makes sense to y'all. And now that we understand the question, let's get into the fun part, the actual solution. Solution is not that difficult at all. So let's get into it. Now, first thing we need to do is we need somewhere to store our output or our result. So this is going to store the number of valid submatrices that we have found. So we'll declare a variable called res, and we can set that equal to 0 to start. Boom. Now we need a running count of x and y within the current row. So we'll declare a variable called xval. Sorry, xval, we'll set that equal to 0. And we'll declare a variable called yval, and we'll set that equal to 0 as well. Boom. Now this array, we're going to create an array that will store the cumulative counts for each column. So essentially this is going to act like a compressed 2D prefix sum. So what we are going to do is we're going to say declare a variable called r, and we're going to set that equal to an array, open up the parentheses of repeating colon, open up the parentheses, it's going to be a tuple 0, 0. Come outside of that, still inside the other parentheses, we're going to say comma count colon grid square bracket 0 dot count. Boom, y'all. Now we need to iterate through each row. So we'll come underneath this and we'll say for I in 0 dot less than grid dot count. We'll open up the brackets and we'll say let row equal grid square bracket I. Boom. Then we'll come underneath that and we need to reset horizontal prefix counts for the new row. So we'll say xval equals 0, yval equals 0. Boom. Then we need to iterate through each column in the current row. So we're going to come underneath this and we are going to say for j in 0 dot less than row dot count. Boom. Then we are going to open up the brackets and we're going to update horizontal running counts and count how many x and y we've seen so far in this row. So we're going to say xval plus equals, open up the parentheses, row square bracket j, come outside of that, equals, open up the quotation marks, put a capital X in there. Then we'll come outside of that, we'll say question mark 1 colon 0. Then we're going to do the same thing for the yval. So we're going to say yval plus equals, open up the parentheses, row square bracket j, come outside of that, still inside the other parentheses, equals, open up the quotation marks y, come outside of that, question mark, we're going to say 1 colon 0 as well. Boom. Now we're going to accumulate into column-wise totals, and this is going to build a prefix sum from 0, 0 to I of j. Boom. So we're going to say R, sorry y'all, we're going to come underneath this, and we're going to say R square bracket j, come outside of that, dot 0, come outside of that, sorry y'all, dot 0, plus equals xval, sorry y'all, xval, boom. Then we'll come underneath that and we'll say R square bracket j, come outside of that, dot 1, plus equals y val. Boom. Now we're going to check if the submatrix from 0, 0 to ij is valid. It must contain at least one x, and the number of x's must equal the number of y's. So we'll come underneath this and we'll say if r square bracket j dot 0, sorry y'all, come outside the square bracket dot 0 does not equal, so exclamation point equal sign 0 and two and signs, r square bracket j, come outside of that dot 0 equals r square bracket j dot 1. Then we'll open up the brackets, we'll say res plus equals 1. And finally, we just need to return the total count of valid submatrices by coming underneath this for loop all the way down here, and we're going to say return res, y'all. Boom, that's all she wrote. Let's give it a run. Make sure it runs properly. Okay, got it. Some pile error. Got extraneous white space. Let's run it again. Let's see, wrong answer. Okay, so if we got the wrong answer, y'all, most of the time that means the math isn't mathing. So let's go ahead. Give me a minute while I check this math real quick. Okay, and here it is. This right here should be plus equals as well. So now let's give it a run and see if that did the trick. Let's see, it's accepted. So let's go ahead and submit it. Make sure it's still accepted after we submit it, because we all know how LeetCode can be. And look at that, y'all. 32 milliseconds beats 100% of users. That's what I'm talking about. That's what I like to see, y'all. So with that being said, make sure you get one more look at the code. This is the top part. This right here is the bottom part. Let me make sure I got y'all the whole code. Yep, this right here is the bottom part. And yeah, y'all, with that being said, I hope y'all learned something today. And I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.